In this lesson, we'll explore the Dunder getitem and Dunder setitem magic methods. These methods define how an object will react whenever we try to index into it. So let's think about indexable objects for a second. Let's compare lists versus dictionaries. When we index into a list, we provide a number to represent the index position. In comparison, when we index into a dictionary, we provide a key within those square brackets. So what these magic methods allow us to do is to define the exact same indexing logic for our own objects. What are we going to extract whenever we provide a pair of square brackets after our own custom objects? So let's begin by taking a quick look at how this works in Python's native objects. Let's take a look at the dictionary as one example. What I'll do here is define a dictionary called pillows, and this will simply be a mapping of a pillow type to its price. So let's say I have a soft pillow, and that's going to be worth $79.99. And let's say I have a hard pillow, and this is going to be worth $99.99. Now, these are all just arbitrary values. The point here is to show you what happens behind the scenes whenever we index into a key. So here's obviously how we're going to write it as a developer. We're going to take our dictionary, provide square brackets, and provide a key like soft. And we're going to get back $79.99 on the right-hand side. And as you might expect, given all that we've learned in this section of the course, behind the scenes, Python is actually invoking a magic method for you whenever you use the syntax. And that magic method is Dunder getitem. And of course, we can invoke it explicitly here. So what I can do here is take my pillows dictionary and invoke Dunder getitem. 2 underscores, getitem, and then 2 more underscores. It's going to take a single argument, which as you might expect is going to be the key. So if I provide soft here, you're going to see the exact same value pop up on the right. Now again, the syntax on line number 7 is a lot less frequently used compared to the one on line number 6, because obviously this is a lot cleaner and more beautiful. But this is how it's working behind the scenes, and we can apply the exact same logic for our own custom classes. Let's go ahead and comment out this code and write a class of our own. So the class that I want to define here will be a crayon box. As you may recall, crayons are those little markers that we played around with when we were kids, and hopefully as adults too, that just allow us to draw pictures. So let's say I'm trying to model a crayon box in code. So here I'm going to define a class called crayon box. And of course in here I'll define a Dunder init, providing itself. And let's say each crayon box object is only going to have one attribute. I'm going to call it crayons. And I'm going to initialize it to be an empty list whenever I create the object. Afterwards, I'll define a add instance method, which will take self, and it's also going to take a crayon. And we're going to represent a crayon here as a simple string like blue or red or yellow. So what I want to do with this instance method is just take my internal crayons list, self.crayons, to get it, and then on a list we have an append method to add on an element to the end, and I'm just going to append whatever crayon is passed in. So the way this will work is if I take a crayon box object, here I am instantiating one on line number 16, what I can do is do cb.add and feed in a sample value for crayon like blue, and below I can, for example, pass in another value like red. And so now in this crayon box object, we're going to have an internal crayons list that's going to have 2 strings. However, our crayon box object, unlike our list, is not indexable. So if I try to tell Python to do something like this, print CB, and I try to access, for example, position 0 or maybe a key, we're going to get an error on the right-hand side. Crayon box object is not subscriptable. What that basically means is it's not indexable. We can't access a specific point in it or a specific position in it. And the reason that is the case is because we haven't defined the Dunder getitem magic method yet. So let's go ahead and do that. So below my add method, I'm going to add a line break, and I'm going to define the method. It's called Dunder getitem. 2 underscores, getitem, 2 underscores. And I'm going to feed in self. It is like all magic methods, it is a instance method. And here I do have to provide another argument, which is going to be index. And index is just my own parameter name, but this is going to represent the key or the index or whatever you want to call the thing that we're going to be using to access the object at some point. Okay. Now, why do we need to define Dunder getitem? Well, for the same reason that we need to define any kind of magic method, which is to provide clarity to Python on how we're supposed to index. So imagine that we had a class where we had 10 attributes and all of them were lists. which list is important, right? Which one matters for the purposes of indexing into an object. In this case, it's pretty obvious if we're going to access a position in a crayon box, like position 0, we're going to probably want to access a crayon since we really only have one piece of data being stored in here, which is this crayons list, right? But imagine we had 10 different lists within a class. Which one is important? That's what we're clarifying to Python with getitem. So all I really have to do here is provide a way for Python to access something within my crayon box given a given index. So I'm going to write it out and we're going to take a look at what it's doing. So here I'm going to return self.crayons and provide index. So what this is saying, this Dunder getitem magic method is hardwired to recognize this square bracket position. It knows to look for that. So whenever Python is going to see the square bracket syntax with our crayon box object, it's automatically going to invoke Dunder getitem. The exact same way that we saw Python invoke Dunder getitem for our pillows dictionary a few minutes ago. So Python's going to see line 24, it's going to invoke line number 16, and whatever we pass in the square brackets, our key or our index position, whatever you want to call it, that's what index is going to be here. So whenever we're invoking line number 24, 0 is what's going to be represented by index, right? So what I'm saying here is that whenever I get an index, all I'm going to do is take the index position at that point in my crayons list. That's how I'm defining the indexability of a crayon box. It's the index position of a value in a internal crayons list. So now when I execute this, we're going to get blue on the right-hand side. And if I do my crayon box and I index into position 1, again, Python is going to invoke Dunder getitem, feeding an index argument of 1, at which point I'm going to take that index of 1 and access that index position in my crayons list. So behind the scenes, what the user doesn't see if they're using just lines 24 and 25 is that I'm using an index position for a list. But again, the important part here is that I'm defining how a crayon box is indexable, right? I'm not doing cb.crayons brackets 0 outside. Outside, I'm doing my square bracket syntax right on my crayon box object, right? CB here is crayon box. That's what I'm indexing into. This is my own custom object, and we just saw a minute ago how this syntax was not working without Dunder getitem because it wasn't subscriptable. Now, because we've defined Dunder getitem, it is subscriptable, and Python simply knows now that whenever we give a index value or an index key or whatever you want to define, we've told Python how to get that value, which is looking at the crayons list and then passing in that index position that we have in the square brackets here as an argument to Dunder getitem. So right now, this is read-only, which means we can index into a position in our crayon box, but we can't overwrite it. So think about a key on a dictionary. We can access it, right? But we can also provide an equal sign and give it a new value. And if we want to establish that for our own class, we need to define a second magic method called Dunder setitem. So below here, I'm going to define it, Dunder setitem. So this is going to take self, and it's actually going to take two parameters afterwards. The first one is going to be the index. It's going to represent the exact same thing as line 16 above. And the second one is actually going to be the value, because we need the new value that we're going to set at a given index. So let me once again write it out, and then we'll talk through an example afterwards. So I'm going to do what I'm going to do here. I'm not going to actually return anything because the goal here is not to give back a value. It's to overwrite a value at a given key. So I'm going to take self.crayons, which is my list, and I'm going to access an index position in that list, and I'm going to overwrite it with a given value. All right, so that may be a little bit confusing, so let's take a look at it in practice. So I'm going to do CB here, square bracket 0 equals yellow. Okay, so 2 minutes ago, we talked about the idea that whenever Python sees a square bracket syntax, like on line 27 or 28, it knows to invoke Dunder getitem. Whenever Python sees that same syntax, but with an equal sign, it knows that you're trying to write a value, that you're trying to set a value. So whenever it sees square brackets with an equal sign, it instead invokes Dunder setitem. The first thing it passes in is index, and the second thing is value. So the value is going to be what's on the right side of the equal sign, and the index is going to be whatever you put inside the square brackets. And that can be whatever. It doesn't necessarily have to be a 0. This can be any kind of a string or key, whatever you want. It's just going to be represented by the argument that you feed in after self to Dunder setitem. So in this example on line 30, index is going to be 0, and then value is going to be yellow, whatever is to the right-hand side of the equal sign. And then what I'm doing is I'm saying take that index position access it in my internal crayons list, and overwrite the value at that index position with my new value, which is going to be yellow. So what this is going to do is it's going to target blue, which is currently sitting at index position 0 in my crayons list, and it's going to overwrite it with the new value of yellow. So now if I access this CB at index position 0, indexing into a crayon box, not a list. We are technically indexing into a list, right? But behind the scenes, on the surface here, on surface level, we are indexing into a crayon box on line number 32. Here we can see yellow up here on the right-hand side. Here's one more cool thing to show you to close this lesson off. The declaration of the Dunder getitem magic method also establishes an implicit iteration protocol for your object. So we can now iterate over our crayon box object in a for loop. This simple declaration has told Python how it's supposed to understand the idea of indexes, and so Python now implicitly understands that you're really going to be iterating over this internal crayons list. That is the concept of an iterable for the entire crayon box kind of wrapper class that is containing that internal crayons list. So for example, if I try to iterate over crayon box for each crayon in CB is my crayon box, I can print the crayon, it's going to access each value inside my crayons list attribute. So we're going to get yellow and red. Yellow is at index position 0, and red is at index position 1. And again, I want to point out what is very important here. Notice here, we are not doing in CB.crayons, right? We are not explicitly accessing the internal list, right? We are technically telling Python to iterate over our own object, over this crayon box object. However, we've told Python that whenever we try to iterate over our own object, what it really should be doing, implicitly we've told it this, is to iterate over crayons. So simply by defining Dunder getitem for accessing an index, we've also told Python how to iterate over our crayon box object. Python has no clue what a crayon box is or how to iterate over it, but it does know what a list is and how to iterate over that. And by defining the syntax, we've sort of tied the two together. It may sound like a small difference because you're saying, well, really under the hood, we are iterating over a fundamental list. And the answer is correct. But the programmer who is writing this, the person who may not know that this code exists, but is using your class or your object in their program, knows that your object of crayon box is iterable and is indexable, or is anything else that we've discussed in this section so far, that it has a length, right? That it has a truthiness, that it has a concept of equality, right? We've made our object super friendly and made it flexible enough to play along with all of these different Python constructs, such as the for loop and such as indexing. Again, that is the whole point, the whole benefit of why we use magic methods. That's all there is to cover in this lesson, so I will see you in the next one.